Hello all, welcome to the video lecture. I am Ramesh Lama. In this video lecture, we'll be discussing about the overview of big data, its characteristics, problems and its applications or factors that made the big data valuable. Before we start with the definition of big data, we see how the data has evolved or how the big data era is launched. Like we can see here from the figure, we can see the evolution of technology throughout the years, like over the past decades. Earlier we had only line phones for the distance communication, but now we have smartphones with the Android or iOS, which makes phone much smarter and our daily life more convenient. Apart from that, we were using floppy disks for the storage, and now we are using hard drive, and we can store the data on the cloud as well. Like we can see, we can imagine, or we know how much the data were stored in the floppy disks. Like it was about the MB 1.4 MB. Like in general, the generally easily available floppy disks were could store data of just 1.4 MB, and we also used the hard disks just for GBs, and currently we are using the cloud for the data, for the storage of data. And we can see that like the evolution of the storage from desktop or from floppy disks to the cloud. And similarly, we can see nowadays the self-driving car which are running across the road, which is also generating the enormous amount of data. If we look at this evolution of technology, we can notice that each of this technology is generating enormous amount of data. Like for example, a single mobile that we are using is generating the huge amount of data with every action we take. For example, a single photo that we send through any messenger app like WhatsApp or Facebook Messenger, this also generates the data. And similarly, talking about the smart cars or the self-driving cars, basically these cars have sensors or cameras that record every minor details, like the size of the obstacle, distance from the obstacle, or the current speed of the vehicle, and many more. And it processes this data and decides how to react, like to go ahead or stop. Now, one can imagine how much data is being generated for each kilometer that we drive on this kind of car. These are few examples for the big data evolution with the evolution of technology. There are other factors which are generating huge amount of data, or which has a big contribution for the evolution of data. One of the feature is IoT, or Internet of Things. I think I hope all of you have heard about it, or if you are working on it, maybe you are much more familiar with this topic. We can say that the self-driving car also is an example of IoT. Like this IoT connects your physical device with the internet and makes that device smarter. Like we can see smart TV, like the smart TV or smart AC. What this smart TV does is like it connects this TV to the internet, and we can use it in more smart way. And while talking about the smart AC, let's see what happens inside the smart AC and how it operates. Like this is This device actually monitors our body temperature and the outside temperature, and accordingly it decides what should be the temperature of the room. Like in order to do this, it has to first accumulate the data. It can accumulate data from the internet through the sensors that is monitoring our body temperature and the surrounding, and basically from the various sources that even we don't know, or we might not know about those sensors. And it's actually like processing that data or fetching that data, and accordingly it decides what should be the temperature of the room. Now we can see, like, because of the IoT we are generating the huge amount of data. Like, it's just a simple example. There are other devices, like we can see here lots of examples that are connected in the internet. Like, we can see the airplanes, like here the pan and the bicycles, even aeroplanes, lights, like which like like television. Like there are lots of things that it covers, and we can see here, like by the year of it was estimated, like by this by the Cisco, it was estimated like in the 2020 around 20 there would be around 31 billion connected devices by 2020, and 75 billions of devices by the year 2025. So like we can from these statistics we can say that how IoT devices are generating this huge amount of data. So this is one factor, that's the generation or the evolution of data. And another important factor that has contributed to the big data evolution is the social media. And I think all of us are familiar with this stuff, like this social media. This is also one of the most important factor in the evolution of big data. Nowadays everyone is using Facebook, like Twitter, Instagram, and YouTube, and a lot of other social media websites. These social media sites have so much data. Like, it will have our personal details, like our name, age, gender. Apart from that, it has data of each each person, and we like and and even like it consists of the data our likes or our react to also, like it also generates the data such as like our reacts and our reaction to some posts on the social media. And we can also share videos on the Facebook, or which is also generating the huge amount of data. So the most challenging thing about here is that the data that we are generating are not presented in a structured manner, and at the same time it is the huge the size is very large, or it is in huge size. So here we can say that the form of data is the main factor of the evolution of big data. So due to the all reasons, and like all reasons, these have not only increased the size of data, but also has shown us that data is generating in various formats. For example, like data is being generated in the form of videos that is also unstructured. Same goes to the images as well, because image also is not the structured, and there are millions of ways where the data is being generated. Here are a few examples, like besides social media and the Internet of Things, there are other factors, like we can see here the retail is also generating the big data, and education, banking, media and entertainment, healthcare, government, transportation and insurance. These are the other factors which are also generating the big data. Like for example, when we use some retailing website such as Amazon or Coupang in Korea or Gmarket, we are also generating the data. When we want to buy some stuffs like bag from the website, we search for a lot of bags, and while doing this, our search is somewhere like it's stored, and our purchase history is also stored in some way along with our personal detail. And these are the numerous ways we might not know that the data are being generated by us. And previously, when no Amazon and no Coupang, and there were no huge amount of data as well, so like there were no data were not being generated at that time. So these are the so in this way the data are also being generated. Similarly, data has been evolved due to other reasons as well, like for example, we can see here banking and finance and media and entertainment, such as Netflix and Amazon Prime and other video streaming websites. So these are also generating the lots of data. And now the point is what the big data actually is. So we have seen how the data are being generated nowadays with the different sources, like whether it's social media or it's media and entertainment, or it's transportation, or it's healthcare or insurance or retail market. Lots of data are being generated. So we have to come out to the point that what is the big data. So actually there is no standard definition for the big data, but talking about the big data, we can define it like it's a collection of large data set. Like we can say, we have seen like the size is very large, and the problem is like it cannot be processed by using the traditional computing technique or tool. Like when we talk about the database, previously when we were using the database, those data were structured, like those were in table, and those data could be processed with some query language like SQL and other programming tools or other query languages. But now as the data is like the size of data is very large, it cannot be processed, and another factor is like it's the data is completely, it may be structured or it's also unstructured, so it cannot be processed using the traditional computing technique. So, and other thing is it has the scale, diversity and complexity require new architecture or techniques or algorithms and analytics to manage it and extract the value and the hidden knowledge from it. So this kind of data cannot be processed, or because its scale, like its diversity and complexity, it cannot be processed with the current architecture or like with the traditional architecture. So it needs some different kind of algorithms or new architecture. So we can say this kind of data as the big data. So with the evolution of big data, problems have also evolved together with it. And when the traditional systems were invented, or when those systems were designed, we never anticipated that we would have to deal with such enormous amount of data. Like those kind of techniques or tools were just designed, or those were invented just for the structured data. So now the question again arises, like how do we classify data as a big data, or how do we know which kind of data is hard to process or is hard for us to process. So to categorize or classify the data as big data, we come with the 5 B's here, and the 5B, like the first one is the or we can say the characteristics of big data, and so to categorize, classify, like let's look closer. Let's have a closer look. What are those? And starting with the first B, is the volume of data, which means we classify the data as big data when it's tremendously large. Like we can see here, as seen in the figure, the volume of data being generated is increasing exponentially. We can see like from 2000 to the 2025, and if we see the pattern of graph, it's the graph is the nature of graph is like exponential plot, and as seen in the figure, it's increasing exponentially, and we can see that there is a big gap between the year 2010 and 2025. We can see, like here it's in 0 and it's in 175 zettabyte, and by the year of 2025 the accumulated digital universe of data is 175 zettabytes, or 100 trillion gigabytes. So we can imagine how much data are being generated and will be generated in the future. So we can say this is it's really huge. So this tremendous amount of data is it's being generated from the multiple sources, and this I got from the source, like the Data Age 2055 report, and it's sponsored by Seagate with the data from IDC Global Data Sphere, and it was this data was this graph was made in 2018, and this is about the volume. Like we can see the characteristics of big data in terms of volume. And another B, or the second B, which is nothing but the variety. Like we can see like the different kind of data is being generated from the different source. Like we deal with so many kinds of files at once, which are, like we can see some audio file or video file or image file, some JSON file, email file, or log files, and so on. This data can be classified, basically it can be classified into 3 major categories, as I have said before. One is the structured, another one is the semi-structured, and final one is the unstructured. In structured format, we have proper schema for our data, or we are familiar with the columns, and we know like we have certain query language to process this data or to extract the data. We can use some query language, and we know the formats, like it's well structured. So this kind of data is easy to process. And when we talk about the semi-structured data, which is nothing but the JSON or XML file or email or CSV file, where the schema is not defined properly. In this kind of, it's not completely unstructured, but it's also not easy to it's not well structured as in the table. So however, and the last one is the unstructured one. Like when we go to the unstructured data, we have log files or audio files or video and images. These are all considered as the unstructured data files. Like we don't have some, the query language cannot be used to extract the content from this images or this data. So this is all about the second B, which is variety of data. And another B is the third B is the speed, and we can see or the velocity, which the like, or we can say it as the speed of the accumulation of the of this variety of data. As we see in the figure, like we can see here, earlier we had mainframe computer systems. These are huge computers but less data, because there were less people working with these computers at that time. But as the computers evolved, we come to the client-server model, and the time came for the web applications and the internet boom. As it grew among the masses, the web application got increased over the internet, and we can see, and everyone started using these applications, and not only from their computers but also from mobile devices. And so more users and more appliances and more hands and lots of data were generated. And when we talk about the people generating data over the internet, the one kind of applications that strikes in our mind is the social media. So if we see the statistics for every 60 seconds, there are like almost 100,000 tweets are actually more than 100,000 tweets generated in the Twitters in every minute. Actually, this data is very old data I presented. In the current time, like the number of data being generated or the tweets being generated or the Facebook status, this data is like this status is quite old one. But if we look now, the data are being generated from the Facebook or from the Twitter, from the instant messenger, and from the search, and the emails are huge as compared to these statistics. Like we can see here, it's like this is the old, and we can see even I think it's more than 5 or 6 year old data. There at that time as well, there were almost 695,000 status updates on the Facebooks. And when we're talking about the messaging, almost 11 million text messages were sent per minute, and almost 455 Google searches, and 160 millions of emails were sent in each minute. It was like this data was this statistics was made for in terms of the 60 seconds. So we can see like the big data, the speed of the generation of, or the velocity of the generation was also very high in big data. And the number of mobile users also are increased. So we can say that lots of data are being generated. So the bigger the problem is now to extract the useful data from here. So that's where we come to the next B, which is the value. Over here, what happens is we need to mine or extract the useful content from the data. Basically, we need to make sure that we have useful fields in our data set, and after that we perform certain analytics, or we say we perform certain analysis on the data. And after that, whatever the analysis we have done, we have some value, which is certain insight of data, and which is not possible to get on the raw form. So we need to be sure that whatever data we have that will help us to grow the business or add value to it, or add value to the data. So getting the value is also one big challenge, and this challenge takes us to the next P, which is the veracity. And actually this big data has lots of inconsistencies. Obviously we take such amounts of big data. Some data packets are bound to lose during the process, we can see here, and some data packets are also now what we need to do is we need to fill up this missing data, then start mining again and process it, and we come up with the good insight if possible. So we can notice here is like our in this example we can see some sort of inconsistency in the table, like some values are missing, and we can see a big gap between the values within the same columns, and so obviously the processing this kind of data is problematic thing. So there is lots of problems while dealing with the big data because of the uncertainty or inconsistencies, and this is the another characteristics like the veracity. So we, while dealing with this kind of data or big data, we have to go through the lots of problems. So however, there is always the different way to look at something. So let's get some positivity in the environment, or let's understand how we can use big data as an opportunity, like that we'll discuss in terms of applications. And applications means what makes the big data more valuable, or how can we use the big data, how can we apply or to get the benefit, how can we benefit from the big data, and we will see that in the next slide.